The Pennsylvania Department of Transportation and the Federal Highway Administration have been working together through Pennsylvania's State Transportation Innovation Council, or STIC, to promote the use of proven and innovative technologies. One example of those technologies is Geosynthetic Reinforced Soil Integrated Bridge Systems, or GRS. GRS is a very old concept that is being modernized with today's technology. Today, GRS uses alternating layers of fabric and compacted stone to create bridge units and can be combined with a variety of beams and a deck to create an integrated bridge system. So, what are the benefits of the GRS Bridge Technique? Mark, a township supervisor in Pennsylvania, is looking for an affordable way to replace a locally owned bridge. Mark has many options for how he could proceed, but he recently heard about the GRS technique. Mark first thinks of regular bridge construction, where he'll have to bid for design and a contractor, as the township doesn't have some of the large equipment or expertise needed. Although Mark is more familiar with the regular construction methods and costs, he's heard good things about GRS. So Mark starts to consider the GRS Bridge Technique. The GRS Bridge will be constructed quickly, minimizing the impact on the traveling public and the community. Mark also knows that the GRS option can be less expensive. In fact, it can lower bridge construction costs by 25 to 60%, which means more bridges can be replaced over time by stretching available resources. The GRS Bridge can be built by local labor with readily available materials. This concept uses less heavy equipment and basic construction concepts. This method is not only faster, but it's also environmentally friendly. And the concept has been used throughout history, including sections of the Great Wall of China that are still visible today. With all the benefits Mark has heard about, he decides to look into whether GRS would work on the local bridge he has in mind. Mark reaches out to his local PennDOT office and speaks with Municipal Services Representative Shelley for more information on how to move forward. Shelley and Mark discuss the best uses for the GRS concept. Shelley explains that GRS is a great option for structurally deficient bridges on low-traffic roadways with slow-moving streams. Municipalities need to look at each bridge on a case-by-case basis to see if the technology will work. The municipality will also need an engineer for permitting and design, and they can utilize local contractors or their own employees. Shelley reminds Mark that PennDOT encourages the use of GRS and has included it in their publication 447, New Products for Low-Volume Roads, which allows local governments to utilize liquid fuels monies for products in the publication. With this information, Mark decides to proceed with the cost-efficient, environmentally friendly, and time-saving option of GRS for his locally owned bridge. So how does it work? First, Mark works with a local engineer to design the GRS bridge. Then he and his staff gather the necessary materials. Rather than drilling a deep foundation, this method builds the structure up in a faster, simpler way, similar to building a layer cake. First, builders create the reinforced soil foundation. Then they lay a row of facing blocks on top of the foundation. Next, they add a layer of compacted stone or fill to the height of the first row of facing blocks. Next, they add a layer of geotextile that extends all the way to the face of the blocks. This geotextile is similar to, but much stronger than, the material used in landscaping projects. Another layer of blocks, compacted stone and geotextile, is placed on top of the lower level. The stacking process is repeated until reaching the necessary height. Sandwiching the geotextile between the compacted soil layers increases the strength of the system and is the key to how the system functions. Once it's complete, the new bridge structure is then placed directly on the GRS abutment frame. The roadway leading to the bridge is then built in a similar way to the GRS abutment with geotextile and compacted stone to transition the bridge to the roadway. Minimal or no concrete is required since the bridge extends naturally out of the roadway. A GRS is built in days or weeks, not months. Without cast-in-place concrete needing to cure or set, the substructure is immediately ready for the bridge beams and deck. Mark's new bridge is open to the traveling public within 30 to 60 days, depending on conditions and material availability, and was built at half the cost of the conventional bridge construction he usually used. GRS abutments alleviate the typical bump at the end of the bridge. Mark has discovered what many others in New York, Ohio, and numerous other states have demonstrated. With the right technology, a good design, and good material resources, a municipality can help improve their own transportation system while saving time and money. These benefits serve not only the local community, but also the entire transportation network by allowing cost savings to be used on more complex projects. To learn more about GRS or other innovative technologies, visit www.moderndot.pa.gov and select State Transportation Innovation Council. More information is also available at the Federal Highway Administration's Everyday Counts website at www.fhwa.dot.gov/everydaycounts.